Today we're going to be talking about force versus mass versus acceleration. So basically, if you guys remember from our first little lecture, F equals ma, right? And with regards to statics, this pretty much sums up all the things we gotta, all the equations we have to know, and then we play around with these variables in various forms, and we try to solve our problems with this basic equation. So that's why it's important to understand the concepts of what each one of these means: F, mass, and acceleration. So for all intents and purposes for this lecture, we're just gonna assume we're working on Earth, okay? And you guys should really know this, that the acceleration due to the force of gravity is abbreviated by g, which is 9.81 meters per second squared. You guys should really know this. This equals the acceleration on Earth. It's a constant, okay? So that's setting our parameters for a little discussion. Constant. Okay. So if we take a look at this, we can say that the force of gravity, again, we're going to make the assumption this is Earth, and I'm just going to write force of gravity, aka force. We can just say force, actually. We can even get rid of gravity, because we already made the assumption that we're only working on Earth. Force equals mass, which is, in this case, we can imagine an object with a mass, which is the it's a measurement in kilograms of an object. It just measures the let me look up for a definition of mass. I found the little definition of what does mass mean, and basically is defined as mass is a measurement that refers to the amount of matter that makes up an object. Okay, that's a little basic definition. So for example, in this case, this little 10 kilogram dumbbell, it's not a force. We have to make that clear, that 10 kg is not a force. When we're talking about 10 kg, this is a measurement of mass of the object, but it is not a force, okay? Not a force. So we can use this and put it into our little equation here. I'm sorry, this should be times acceleration, okay? So we can put our little 10 kg, right, from a little weight, and then we multiply that by the acceleration on Earth, which is 9.81 meters per second squared. And that right there is going to give us our force. So if in this case, if we multiply 10 by 9.81, we're going to get 98.1. Let me do it. Let me write it here. 98.1. And then when you multiply kg by meter per second squared, you get newtons. Newtons of force. So this is basically the force on Earth created due to the gravitational pull of the Earth, and that is acting on this mass. That's basically what this means. It's pretty simple. But let me know in the comments if you guys have any questions or anything like that. Okay. So here we're going to do some more examples of this. And here's a little table that I found useful that might be able to help you guys out a little bit. So let's do an example. Imagine we have a 5 kilogram object. Let's call it a 5 kilogram sack of potatoes. I don't know, sack of potatoes. Sack of potatoes. We have this little sack of potatoes, and it has a mass of 5 kg, right? 5 kg. And we're asked to find the force of the force. The 5 kg acting on the Earth. So let's go. So we would say the force equals ma. This, we always go back to our equation, okay? So force in this case, it's going to be equal to the 5 kilograms times the acceleration on Earth, meter per second squared, 9.81. And then we just multiply this, and it'll give us about, let's say, 49. It's 49 newtons of force. So imagine you have this little problem where you're asked to find a reaction from the floor due to a 5 kilogram sack of potatoes, right? So imagine this is the Earth, right? Here, the floor. So your 5 kilogram sack of potatoes is going to be acting down like this. Again, this is due to the force of the Earth. So now you know your force here because you did your little problem. Yeah, so then we go here, force equals that. And now you need an equal and opposite reaction from the floor. So your floor has to give you an equal and opposite reaction of what? Of 5 kilograms. I'm sorry, I made a mistake. The force unit is 49 kilonewtons. I'm sorry, not kilonewtons, just regular newtons. This right here. And that's basically it. I suggest you guys play around with this little table here to kind of get familiar with other units of force, mass, and time that we have. For example, I like using the SI unit because it's very simple. It's the most commonly used around the world, I believe. But you guys should also get used to these other unit systems because you guys might live in an area where you guys use that system. And this is basically the I guess let's summarize real quick. So a mass is not a force. For example, the dumbbell is not a force. A 5 kg object or a 10 kg object is not a force, does not equal a force. It needs to be acted on by an acceleration to be a force. So 10 kg object times an acceleration, which is measured in meters per second squared typically, will give you a unit of force. You cannot have a force without an acceleration. And the reason why we have force on Earth is because of the gravity that's always acting, the gravity force that's always acting on Earth, creating that acceleration constant, okay, on the Earth, which is 9.81 meters per second squared. Without this gravitational force, there would be no acceleration on your object, so then you wouldn't have a force. So I hope this video helped you guys, and let me know if you guys have any questions or comments or concerns. Thank you.